Okay, so today's date, 2/12/18. So, what we're talking about, common core standards, we're talking about polynomials. Polynomials. And the big key that we need to write down, it must have whole number exponents. To be a polynomial, it must have whole number exponents. And we saw from the graphs that they become curvy lines, right? And the bigger the degree, the more curvature it has, right? And that's what makes it. Whole numbers are the numbers. Whole numbers, if you don't know, whole numbers are the set 0, 1, 2, 3, dot, dot, dot. That's a set of whole numbers, okay? If it doesn't have a whole, if it has a fractional exponent or a negative or a decimal exponent, it is not a polynomial, okay? So first of all, I've got 1, 2, 3, 4 terms. Now listen carefully. There's a monomial. There's a binomial. There's a trinomial. But at a certain point you go, this could get ridiculous. So we don't call it a quadnomial. We don't say pentanomial. We don't say hexanomial. It seems silly. So anything over 3 we just call a polynomial, okay? So if it has more than 3 terms, its name is just simply going to be a polynomial. Okay? Anything over 3, if it's got 4 or more, just call it a polynomial, okay? Degree is 4. The degree is the largest exponent. It's degree 4. Its leading coefficient is the number in front of the biggest term. And that's this 3 right here. Now the constant. To be constant, it never changes. Things that vary change. So the constant has to be the 1 because it's not with a variable. It won't change, right? So the constant is the 1, okay? The constant is the number without a variable, okay? H of x. H of x is a trinomial. 1, 2, 3 terms. The degree is degree 3 because it's the largest exponent, okay? The leading coefficient is the 5. Now it's not leading, so I'm going to rewrite h of x because I need to write it in standard form. So I'm going to rewrite this one. So I put the 5x cubed first. Minus 3x plus 10. Because it should be rewritten in what we call standard form. Standard form is biggest to smallest, okay? And so then I know my leading coefficient is the 5. And the constant is the 10. Thumbs up. Doesn't seem like math at all, does it? Isn't that great? More like English, right? Okay. J of x is a trinomial, right? That's a trinomial. It is in standard form. Trinomial. It is in standard form.
Wait, but Mr. Davies, it's at x squared, not x cubed.
This one was x cubed, though, right?
Yeah.
Yeah.
So why would that be a trinomial?
It's 3 terms. 1, 2, 3. Thank you. Great question. Doesn't matter what the degree is. If it's got 3 terms, it's a like a tricycle. It's 3 wheels. Like 3 terms. Okay. Trinomial degree is 2. My leading coefficient's a 1. We don't normally write the 1, but there it is. And the constant is 3. Right? Bailey's like, I got this. Right? Yeah. Yeah, Renee.
Why would it be a trinomial if it's 3?
Right, and there are 1, 2, 3 individual pieces to it. So there's 3 terms. Okay. So regardless, it's got 1, 2, 3. Now look at this one. It's got 1, 2 terms, right? So this is a binomial, right? Binomial. The degree is 1 because of this 4x. This x has a power of 1, right? Has a degree of 1 because this has a little 1 right here. We just never write. Leading coefficient is 4, and the constant's 1, right? F of x equals 5, all by itself. All by itself, it's just only 1 term, so it's called a monomial. Degree is 0 because we could write as a 5x to the 0 power. We wouldn't normally write as a 5x to the 0 power, but we could, right? It has no x, so its degree has to be 0. It doesn't have a leading coefficient because none doesn't really have a leading coefficient. We'll say none, but we'll say the constant is itself, which is 5, okay? All right. Example 2. So here's the rule. When we add or subtract, we combine like terms. Okay? Combine like terms. Okay? So we're going to put together the ones that go together. Okay? Do not add exponents. Do not add exponents. Do not add exponents. Here's a 14x cubed. Are there any other x cubes to combine it with?
No.
Nah. So my answer is 14x cubed. I got a 3x squared and a 1x squared makes a 4x squared. Do not add an exponent. I can talk really. 3x squared, 2x squared makes a 4, a positive 4x squared. Not x to the fourth. When you add terms, don't add exponents. Natalie, can you see it? This is a 3 there and a 1x here.
No, there's 14.
Oh, that's a cube. That's a cube. That's 3. Okay. I've got an x and a negative x that kind of cancel each other out, right? Degree of these two just gone. And then finally I have a 7 and a 2 makes a plus 9. Okay. Yeah, this is easy, isn't it? Just don't add exponents, okay? If you're going to add terms, don't add exponents, okay? All right. Now, when you subtract, you don't have to do this, but this is my suggestion to you so you don't make mistakes, because you guys hate making mistakes. I will always try and bring the negative through first, because I don't like to get tricked with double negatives. The double negative thing confuses me. So when I subtract, I'm going to rewrite it as a negative 3x positive x squared minus 2x cubed positive 10. So before I subtract polynomials, because of the parentheses, I just make sure I don't mess up with the double negatives. That's why I push the negative through, okay? Negative 3x positive x squared negative 2x cubed positive 10. Because for me, I'm going to make a mistake. I know I am. So I don't want to make a mistake. So I don't make a mistake down the double negatives. Now I'll bring back down the 2x cubed plus 4x minus 2x squared plus 3. And now I'll combine terms, okay? Kind of squished in there, but it's all good. Okay, I got a 2x cubed and negative 2x cubed, right? Cancel, right? These two just cancel each other. Psh, gone, psh, right? I got a negative 2x squared and a positive 1x squared. Negative 1x squared. Okay. I got a 4x and a minus 3x, right? 4x subtract 3x makes a positive 1x. And then I've got a 3 and a 10 makes a positive 13, okay? So, again, when I see subtracting polynomials and a parentheses, I try and push the negative through first so I don't make mistakes with the double negative, right? Just trying to eliminate the double negative thing by pushing it through, okay? All right, now, example 4 is a FOIL problem. It's a big FOIL problem. You can't really call it a FOIL problem because we got a lot to, so we're going to multiply. Okay, you ready? Step by step. We're going to FOIL, kind of FOIL. Let's really distribute. So we're going to take, and I'll say it and then I'll do it. We're going to take the 3x times all 3 of these terms. Then we're going to take the negative 2 times all 3 of these terms, okay? So you ready? 3x times the 2x squared is a 6x cubed, right? 3x times the 2x squared. 3x times the 3x is a positive 9x squared. 3x times the negative 1 is a negative 3x. Now let's deal with the negative 2. Let's go negative 2 times the 2x makes a negative 4x squared. Now I'm going to put it right there. I like to line them up because then when it comes to add and subtraction, I just like to line them up. X squareds with X squareds, right? If I line them up, then it's easy to add or subtract. Then I'll get a negative 6x. I'll put it right there. Same thing. I like to line them up because it makes it easier to add or subtract them. And then finally, I'll get a negative. Oh, I'll get a positive. Sorry, my bad. Positive 2. So now the nice thing is by lining them up, then to finish it up, everything's lined up, okay? 6x cubed. See, it is the only x cubed, so 6x cubed. Plus 5x squared minus 9x plus 2. Bailey's going, I got this. Got this, okay? Okay, is ready to turn the page? All right. All right, now, let's put some of these on the calculator. If you don't have a calculator handy, that's okay. You can watch me do it, okay? You can just watch. Might be just easy. So, first of all, I said 10 scales. So right back, I'm going to go to my window. I'm going to go -10 to 10. And scales by 1. I'm going to go -10. Oops. Nope, -10 to 10. Scales by 1. So right off the bat, okay? Before I graph this one, what do you think it might look like? What do you think? Right? It's a cubed, right? Do you remember what it might look like? It might look like this. You agree?
Yeah.
It might look like that. So let's just graph it and see. Okay, I think, so I go to my y equals clear 2x to the third power minus 3x. Let's see what it looks like. Delete that. Graph. Hey, what do you know? Looks just like what we thought it was, doesn't it? Doesn't it look just kind of like what we thought? Yeah. So it goes through here, here. Looks something like this, right? Okay. Okay, does that make sense? My zeros appear to be at x equals -1, x equals 0, and x equals 1. It appears to be that, right? My zeros there, there, and there, okay? And again, we're going to get the zeros exactly, but for right now, we're just going to guess them. I'm going to show you how to get them exactly, okay? Okay, B, what do you think B is going to look like? Got an idea? What do you think B is going to look like? It's next to the fourth. What do you think B is going to look like? Kind of like the W, right? Kind of like maybe the W, right?
Yeah.
Probably is. Let's take a look at it, okay? I think it's going to be the W. Let me put in my calculator, so I'm going to go, okay, y equals x to the fourth power minus 8x squared plus 1. Let's graph that. Yeah, it looks like a W, doesn't it? Right? Looks like a W. So it's going to look something like, it doesn't have to be perfect, something like this. And we'll get these exact values later. For today, we're just going to guess at what they are, okay? So my zeros appear to be at x equals -3, maybe x equals -1/2, x equals +1/2, and x equals 3. Now, are they exactly these answers? I don't think so, but I don't really care right now what the exact answers are. Tomorrow, I'll show you how to get the exact answers, okay? Okay. And C, you know what C looks like, don't you? Right? You guys know what C looks like. Starts with a P. What's C look like? Right? And it goes through it in 1, 2, 3, 4. I don't need a calculator to do this one. I already know what it looks like. It looks like that. Right? My zeros appear to be at x equals -2 and x equals 2. All right? Okay. All right, last example. Oh, so sorry. Whoa, so sorry. That's all right. So all we need to know today is this. Polynomials are curvy. You with me on that? And if we add a degree, it gets curvier, okay? Polynomials are these curvy graphs, right? Polynomials describe things in business really well. You want to see a business model? Okay, here's a business model. You open a restaurant or a business and things are going great, 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 great. And you get to right about here and you say, dang it, let's open another restaurant so we can make some more money. So what happens? You take a dip in profits, don't you? But then, once that other restaurant's open, all of a sudden you start to make a greater profit, don't you? That's a good business model right there, okay? Okay, last but not least, f of 0. How do you find f of 0? Yeah, so you got f of 0, make all of these zeros, so if I've got f of 0 is equal to 8.0056 times 0 cubed minus 22 times 0 squared plus 2.33 times 0. What do you get? Well, you should get 0, right? Right? Girls, all I did is I plugged 0 in.
Oh.
That's all I did, plug 0 in. Alright, and that's got to be 0. What does that mean? Well, you got a cardiac patient. If you haven't injected him, then the medicine isn't going to work, right? Pretty much. So time is 0. There's no medicine. You're not going to get any output, right? So let's see what happens after 3 seconds. So we'll go F of 3 is 0.0056 times 3 cubed minus 0.22 times 3 squared plus 2.33 times 2. 3, thank you. Oh no, it's not okay. I appreciate you, I do. If I plug that in, let's see what I get. 0.0056 times 3 cubed. Keep me honest, Claire. 0.22 times 3 squared plus 2.33 times 3, right? 3. And I get an answer about 8.7.
Wait, David, can you put the calculator back up?
Yeah,
Isn't it?
Yeah, didn't you
we have
just-
subtract?
Yeah,
the point
you got it.
darn me, it's Monday. 1.256 times 3 cubed minus 0.22 times 3 squared plus 2.33 times 3. How's that look? 5. I got a different answer, about 5.16.
What is this?
Must represent how much is in the bloodstream, how much medication. So it'd be represent how much. Yeah, parts per million. Yeah. There you go. Okay, pretty easy. So here's our homework. Let me highlight it. Okay. Oh, you guys need a new stamp sheet too, don't you? I'll get those to you in just a second, okay? And I'll stop recording, okay?